Okay, good morning. It took me about half hour this morning to set up my stream for some reason. Things were not configured right, and I have no idea why not, because didn't change anything, but you know, that's how things go, I guess. Let's switch over. I had to restart my session, so everything is all wrong. Where did we leave off yesterday? Synacor, we had just finished figuring out these are the steps that we take through the game, right? And then I added an @ sign to turn on output mode. SVM, yeah, has the extracted algorithm. So if we take a look at that, so before we start the algorithm, it sets R0 to 4 and R1 to 1, and then it calls 178B, and this is what we extracted yesterday, trying to figure out what the algorithm is. And this looks like it's all self-contained here, and then we have to figure out what value is supposed to be set for R0, I guess, because that looks like that's the return value. It adds R1, it adds 1 to R1 and then returns R0. Oh, it stores it in R0 and then returns, so I'm assuming R0 is the return value. But we don't know, I haven't disassembled the code after this. So I was thinking that maybe what we could do is just say if we're at 178B, then we can just inject a return statement and just have it return directly, and then we can see what happens after that. That would be a good first thing to try before we try to mess around with this algorithm. So let's take a look at figuring out how to do that. And I think it's just as simple as, instead of just grabbing the instruction, we can just say if machine.idx is equal to this value, then return, and instruction is what's the return instruction? 18. So it's 18 else that, right? And we don't have to worry about incrementing IDX, because IDX is going to get reset as soon as we come down here, and we call jump to. We call pop, and normally we'd have to increment IDX to go past the instruction. But I think this will at least return from the instruction and allow us to figure out what's going on. Oh. Like that. Why is this an extra layer? Oh, there shouldn't be an extra layer. There. Okay, that works. So now we should be able to say cargo run steps, and then we can dump that into the output. It's okay if we overwrite output because we're just generating the same thing. Ooh. Now it panicked. Let's see what the output looks like. The last thing it was trying to do was get an in. So it must have written something to the console. Let's see what happens when we look for what was it, 17, oops. Less. Right. We call 178B, so we would have printed that maybe? Let's take a look. 178B. Yeah, and then we just say return. And now it's saying is R1, sorry, is R0 equal to 6? Jump if false to 15CB, and then it goes to 15CB. And it looks like we're writing some output. So let's see if we can take a look at the output. Yeah, so let's take a look at what the output says. In order to do that, it'll be easier if we don't have this debugging stuff here. So let's take that line out. Try again. I'll put this one in output too so we can compare. I think what's happening here is we're trying to grab some input and there's no more input, so we just panic. So what does this say? Miscalibration detected a porting teleportation. Nothing else seems to happen. Okay. So it's expecting, if we look at the output again, it's expecting R0 to equal 6. So we can just do that too, right? Is this too hacky of a way to solve this problem? We can say, before we do this, we can say machine.reg0 is 6. And then return 18, right? Register. I forget what I called it. There we go. And now we can see. Let's rerun this here. Okay, you wake up on a sandy beach with a slight headache. The last thing you remember is activating the teleporter, but now you can't find it anywhere in your pack. Someone seems to have drawn a message in the sand here. It begins to rain, the message washes away. You take a deep breath and feel firmly grounded in reality as the effects of the teleporter wear off. Beach. This is a sandy beach in the cave of a tropical island. The ocean is to your south and heavy foliage is to your north. The beach extends to your west and east. Okay, so we got a code. Ooh, conform. No, I don't want to resubmit the form. Okay, so let's go here. That's me. Okay. That's not a valid code. Interesting. Interesting. So I wonder if there's code that, maybe it uses, we have to figure out what the correct value needs to be for R7, right? Because this is what kicked this whole thing off, is we had to set something in R7. Yeah, here's what we're, and this code doesn't work for whatever reason. Oh, reg. That's why the code doesn't work. Right, register 7 has to be non-zero. but it has to have a value. And we're setting, what do we set it here? Right, the first time we do an input, we set it to 1, but obviously 1 is the wrong value. So now I'm guessing that, let's save that. Now I'm guessing that based on the output 2, we need to actually set it to the correct value in order for this code to be right. That's my guess. So let's take a look at the algorithm again and see if we can implement this somehow faster, right? What is this doing? Let's create a new little window here. We can dump it in here so we can look at it at the same time. Make it nice and big. And then there. Okay. So we already have 2 programs in here. We have the solver and we have SVM. So we have to create a new cargo new algo. Okay, so what is this doing? Let's see. Let's assume this is a function, and I don't know what you want to call it. Let's just call it algo, I guess. And it takes, right, it took 2 arguments, R0 and R1. And I see it using R0 and R1 everywhere in here. So we can just call those here. I guess this is U16s, R1, and it returns a U16. So what is this doing? It's saying jump if true to 1793. So that means if R0 is not equal to 0, that's what true means, then we're going to do this code here. If R1 is not equal to 0, then we're going to go to 17AO, which push R0, subtract 1 from R1, and then call So how do we do that in Rust? So it's just calling algo with R0 and R1 minus 1. And then it sets R1 to R, so sorry, this says set R1, R0, and I think it's right to left. Set register A to the value of B. So that in Rust code would be set R1 is the result of the call. Because R0 is going to be the result of the call and pop R0, right? That way R0 doesn't change. And then we're going to subtract 1. We're going to subtract 1 from R0. And return that in R0 without pushing. If this is false, then we're going to subtract 1 from R0. We're going to set R1 to R7. Oh, which is our magic number. I guess we have to pass that in. R1 is R7. And then we're going to call... Oh, And then we're going to call the algorithm, and then when it returns, we're going to do this. Okay, so maybe the right way to do this is if R1 is 0, R0 minus equals 1, R1 is R7, and then we do this. If R0 is 0, then we're going to return R1 plus 1. Here, what are we returning? We're just returning R0. Is this it? This looks weird. And I'm not sure it's right. Oh, R7. Oh. Yeah, I forgot that this was an, yeah, but if that's okay if we make it mutable, right? It won't mutate the because it's still going to copy the value. Okay. So what happens if we run this? And we gave it 4 and 1, right? Those were the oh, it's in SVM. Extracted out. There we go. Yeah, 4 and 1. So println if R7 is 5, algo is this, and then we'll just say algo 4, 1, 5. And this will probably take forever to run, right? A billion years? Attempt to subtract with overflow. Ooh. That's not good. On line 8. Oh, okay. If R's, yeah. This line 8 means R1 must be 0 at this point. If R1 is 0, I said it's 7. And it's 5. So it wouldn't be... Okay. Well, we're going to get a lot of output, but that's okay. 0, 1, and 7. On line 9. Oh, I was on the wrong line. Okay, so if R0 is not equal to 0... Oh, is this mutating thing messing us up? All right. I don't know if this is the issue. We'll call this R0 input and R1 input let. There. Okay. Nope, same issue. All right, but we can see what's going on, right? 415 is what we call with. And then the next run is 315 or 355. Is it? There must be something wrong with this algorithm here. If R0 is Maybe we just implement it the exact way and see what happens, and then maybe we can rearrange it. I'm thinking now we should have a global variable and a stack to do this. Because I don't think I'm implementing exactly the right way, but let's try this. 16. And it reveals or returns a U16. Okay, so jump if true to 793. If R0 is not equal to 0, equals 0, then jump to 793. So 1793. All right, this was the issue here, is it calls this and then it pushes. Right, because this modifies R1. Oh, maybe that's what we need to do, is return a tuple of R0 and R1. Maybe that's a better way to do it. So if R0 is 0, then we're going to add 1 to R1 and return. So we return, sorry, we're going to add 1 to, R0 is going to be R1 plus 1. And we're not going to touch R, so this is R0 plus 1 and R1. No. Right, we don't touch R1, and we add 1 to R1 for R0. Okay, so that's that. Otherwise, we're going to say if R1 is true, it's going to skip over this part here. Okay, so we'll say if R1 is false, we're going to do this part. We're going to set R1 to, we're going to add or subtract 1 from R0 and set R1 to 7, R7. And then we're going to call algo. So maybe this says R0, R1 equal algo of R0 minus 1 and R7. Then we say push R0, subtract 1 from R1. So we're going to save R0 somewhere. We're going to subtract 1 from R1 and call let's say R0, R1 is going to be equal to algo of R0 and R1 minus 1. And then we're going to say R0, R0 push. Oh, we call it, and then we set R1 to R0. Like that. Push. There's the pop. Then we're going to subtract 1. From R0, and then we're going to call the algorithm again with that value. And the R7. I keep forgetting the R7. And then this is return R0, R1. All right, let's try that. Destructuring assignments are unstable. But you can do this, right? And then say R0 equals R0x and R1 equals R1x. And then we have to do the same thing here. Let me just see if that works. Yeah, it does. Okay. So then we say R1 equals R1x. And then here, right, because we're setting, this sets R0 to R1, pops R0, which throws this away. And then we assign these guys here and return them. All right, and then we're looking for 6. Ooh, thread main is overflowed its stack. Okay. So where do we... I mean, we could try printing out all this stuff, but oh, well, I mean, we only have U16, right? That's all we're worried about. So we've only got 65,000 things. Well, 65,000 squared, I guess. It's more than I was thinking. Oh, except the numbers are fairly small, right? Well, until we get to this, R7, right? When we set R1 to R7, then the numbers get bigger. But it's only that one. So maybe we can, I'm thinking maybe we can memoize this. What would that take to memoize this? If we create, I was thinking, okay, we can't do a global. So let's see. There's lazy static, right? Which I've used before. So I can say cargo add. So I'm thinking I can just create a lazy like this. Do I have to use it, or can I just use it as a macro? Static bang. And this is going to be static ref. What should we call this? Memo. And it's going to take in a tuple. This will be a hash map. Of a tuple of U16s. And the result will be a U16. like that. And we can just use it, right? Yeah, okay, so this should check. And then we can do this thing here if, oh, these should be options, right? No, that's fine. If memo oh, damn it. I'm trying to return a single value. Guess we do it this way. Contains key R0, R1, then return memo get R0, R1, unwrap. Otherwise, what is this going to return? We'll memoize this thing. Memo insert R0, R1 with R1 plus 1, R1. And then this returns here. Oh, we've modified things here. R0 original and R1 original. Like that. And then we can say memo insert R0 original, R1 original with R0x, R1x. Oh. And we can't borrow as mutable. You? No, that's even worse. You have to be able to mutate it, right? What am I missing here? Oh, I have to do this. Lock. Unwrap. No, it doesn't like that either. Oh, I have to wrap it in a mutex. Okay. And mutex. New hash map new. And then down here. And we have to pull in mutex. Lock. Unwrap. There's probably a better way to do that, right? And we have to do it here. Okay. And does this also... Yeah. All right, I'm doing this all wrong, aren't I? Oh, I was gonna put this up here. All right. So let's print these as we find them, I guess, and then see what happens. 0, 1 converts to this. Now, I have no idea how to determine whether or not the values are correct. And then this here, this is R0x and R1x. Even before it printed out the first one, we're getting 0.5 to 6.5. So I'm not.
All right, let's bring that beat down.
I'm going to say called with these values. And we'll see if this looks somewhat reasonable. Four 1, then 4 0. Is that the next thing that should happen? Is okay. So if R0 is non-zero, then we go to 793. R1 is 1, so we go to 7AO. We push R0, subtract 1 from R1, and then call. Yeah, so that's what we did. We subtracted 1. Now we come up here. This also jumps to 793, but now we say subtract 1 from R0, set R1 to R7, and call. So that's what we got, 3.5. So we get down all the way to 0. Okay, so this is... So what we should be saying is that if you call with 4.1, our return value should be 6.5. And then we keep running and running and running and running and running. And at some point we should be saying, yeah. So here we should say 4.1. Oh, 4.1 exists. We shouldn't have to keep going. So what's happening is we're just memoizing the wrong thing. Yeah. Is this correct though? Should we be returning 6.5? So if we call it with 1.0, we do the thing. Right, we subtract. Well, so now they're both 0. So we come here. This is false. So we add 1 to R1. Sorry, we return R0 should be R1 plus 1. Oh, because we called it with 0.5. Yeah, so then it returns with 6.5. Huh. If it returns with 6, that's the number we're looking for, right? But we keep going. Okay. So I think what's happening is I'm just memoizing the wrong thing. I didn't do my memoization correctly. So I think what we need to do is say we want to we want to get the return value here and memoize this. not what we're going to return. We want to say, okay, this algo with R0 and R1 minus 1 return this value. Yeah, okay, so when we're called with 0, 5, we're going to return 6, 5. So that's the answer. So that's right. And here it looks like it did. It looked it up and it found it. And we can confirm that just by, okay, so maybe it's right. All right, we can check that. Yeah, so we call it with 0, 5 and we get 6, 5. There's another 0. Why isn't it going to the next one? Oh, it is. It's just the same over and over and over again. Okay. That doesn't really help, does it? Because if it's the same over and over again, I must have this algorithm wrong. And now it's all interspersed with this memoization. Well, we're calling it with 6.4, and once we call it with 6.4, right, we go through the same thing. This is true. I'm looking at the 6.4 case here, or the 6.5 case, right? After we return, oh, maybe that's the issue here. So where are we returning from? When we call 0, 5, we're returning from here. We're adding 1 to R1 and storing that in R0, and then we return. And now we return back to some other location. We return here, right? Because we just set this. So now we push R0, which should be R1 plus 1. We subtract 1 from R0. And then we call again. And then we work our way down. Yeah. We're never hitting this return. All right. I must be translating this wrong. My brain just isn't working for this algorithm. Rust static global. We don't do global variables in Rust. So how did we do it? The idiomatic method. Okay, so I can do that. Let's do this. I can't just. You can't do that, right? Yeah. Expected item found keyword let. Yeah, that's not going to work. Okay. So can I say static? Come on, let's get to it. What I want, I'm looking for being able to set R0 and R1 globally, like the machine has it. Okay, so you can do that. And then we don't have alpha. Okay, so this is good. Or U16. And now I should be able to say R0 equals 4, R1 equals 1. And then we can say algo with 5. And then call algo here. And that's going to be R7. And it'll just return R0. Okay, so then we can just do this directly, right? If R0 equals 0, then we're going to say R0 equals R1 plus 1. Return R0. If R1 is 0, I'm going to say R0 minus equals 1. R1 equals R7. And then we're going to say algo R7. And we're going to say let push equals R0. R1 minus equals 1, algo R7. That's that line, and then we're going to say R1 equals R0, R0 equals push, R0 minus equals 1, algo R7. Return R0. And that looks so bad. And it doesn't even compile. Use of mutables. Mutable stacks can be mutated by multiple threads. Aliasing violations or data races will cause. Use of mutable static is unsafe and requires unsafe function or block. Okay. There's only one thread, so I think we're safe. Wait, I just did an unsafe. Oh, I have to do it here too. I guess I don't because I already initialized them to 4 and 1. Okay. 6 warnings. And we still have a Stack Overflow. So now, do we try to memorize this? Okay. Oops. So let's put this here. Oh, right. Okay, so let's do this. And this is just going to be, yeah, that. So we're going to get this and then put it here. And we're going to say R0 equals red 0, R1 equals red 1. Return R0. And then for this, we're going to say, after this, we're going to memorize that, right? What do we do up here? Oh, just before the return statements. Okay. Oh, but we don't know what the original values were. R0 original equal R0. Okay, so we save those that way. And then before we return, we can do this. Ah. That. Like that. Oh, that's before the return statement. All right. I have no idea how this is going to behave. Oh. Okay. Where can we do different prints? And over here we can just say inserting like this. And then down here we can do the same thing. And see if this does anything. Oops. Okay. It's finding a lot of 6.5s. Okay, so it's the same exact thing, same exact problem. Even though I rewrote the algorithm completely, it looks like we're ending up with the same things. Let's print out the call again And it's probably going to be the same thing as before. And we just end up with a Stack Overflow. Yeah. And it's just, it would seem to be in some sort of an infinite loop. Whenever we get 0, 5, we're able to store, we inserted for 0, 5, we inserted 6, 5. But we're not, that's not helping us along any other path, code path here, right? Because we can't seem to get out of now when this was running. Oh, well, we can try R7 of 1. That's what we had before, right? I'm putting 5 here, but I put 1 in for the other thing. And let's see what happens with that. It still aborts, but the algorithm is a lot shorter. Let's see if it all makes sense. You do the 4, 1, 3, 1, 2 all the way down to we're called with 0, 1. So 0 means take R1 and add 1 and store it in R0 and return. That's true if we're called with 0, 1. We're inserting a 2, 1. That doesn't seem right, does it? Oh, it's returning 2, 1, right? Because whatever is in R1 gets added 1, and then R1 gets left alone. So we return 2, 1. So now that we've returned this, we call it again. But we should be coming down here, right? And with push R0, which is pushing the 2. Subtracts 1 from R1 and then call again. And that's how we end up back here. But we're never popping back. Did I misread that? I think I'm not misreading it. Add. Where's add? Assign into A the sum of B and C. Yeah. So R1 plus 1 gets assigned into R0. Okay. The problem is that, we're calling this, and now we're in the next layer down. And this is the only time we've ever inserted something, which means it's the only time we're actually hitting a return statement. Here we're just doing a call after call after call after call after call. And we're never getting to the second return statement. Let's see if this is the same way this behaves in the code. That's how we can see if I've translated it correctly, right? So if I go in here, and right now what I have is if I hit an @ sign, where is it? Yeah, if there's an @ sign, then I've toggled the dump flag. So what I can do is, and then I was setting the thing to 6. Where's my 6? Oh, it's going to be a bunch of 6s. Yeah, Okay, so let's not do this anymore. Let's take a look at the algorithm properly. Like that. Oop. There. And then we can actually, instead of dumping out just this, we could also dump out the value of the registers on each line. Should we put that right before here? Yeah. And then we can watch the algorithm run for a little bit. I have to put the @ sign back in here, and then cargo run steps, and then put this into output. Let it run for a few seconds, and then kill it, and then we can see, oh. Okay, so if I look here, oh, this is, yeah, now my access thing is working correctly. All right. Taken. All right, so the last taken is this one. Okay, so then we set this. Oops, what did I do? No, wrong key. There we go. Then R7. Okay, so here's the access. I got to turn off the access thing now. All right, so this is our algorithm, right? It starts at 178B. There. So 178B. We can see the values are set to 4, 1, and this is set to 1. And then every call should match up the 1 and R0 and R1 should match what we're seeing, so for every call. So it starts at 4, 1, then 4, 0, then 3, 1, 3, 0, 2, 1, 2, 0, 1, 1, 1, 0, 0, 1, 0, 2, 1, 3. Okay, so I'm not seeing that, am I? Let's take a look here. Oh, this isn't big enough, is it? The font, I mean. I think I did 1, 2, 3, and then make it smaller again. So one thing I don't like about iTerm is it has to resize the terminal, and in order to resize that, you have to resize that, and then new terminals don't start up with the right size. And okay, dev Synacor, algo. Okay, so let's see. 4140, 3130, 2120, 1110, 01. Right? So maybe this is where our bug is. Oops. I guess we can look for the first call. Oh, 178B. Nope. 178B. There we go. And there's the first call. Okay, so we can look at these now. So actually, we can just grep for that. Grep call 178B, and we can take a look at each of the values. So 4140, 3130, 2120, 1110, then 01, and then 02. I'm not seeing that. I'm seeing 20. So maybe that's the bug. Because the next thing this is doing is a 02. So, yeah. Call 01, and then the next call is right here. So it's these steps that are not working right. So when we call 0, 1, right, we're returning 2, 1. And is that what's getting returned? Here's a return. Yeah, return of 2, 1. And then there's a second return. And then it's calling set R1 to R0. We pop R0, so now it's 1, 2. So it's 2, 2, we pop R0, it's 1, 2, and then we subtract 1 from R0 and then 0, 2. And then we call again. So we should be calling with 0, 2, and I'm calling here with 2, 0. So that's the bug over here. Where is it though? I'm subtracting 1 from R1. I'm calling the algorithm. I'm popping R0. I don't know, maybe we can watch these one line at a time. We'll just do this. So every time we change something, we'll just print it out. And then over here, I don't know. I don't know if I'm going to be able to interpret any of that. Okay, so here's 2, 0. Right? Um, 2, 1 is our first return, and then a second return. So we should see it go. We should see it do this, right? But it's calling it straight away. Okay, let me give it instructions then. This is the call. This is the return. Okay, so this is, what line is this? This is add R0, R1, 001. And return that. This is add R0, R0, 7 FFF. This is set R1, R7. Which one is this? This is add R1, R1, 7 FFF. Too many Fs. This was the result of the call. Then we have pop. Oh, set R1, R0. Pop. Oh, I missed the push, didn't I? Pop R0. Push R0. And then this final one here is add R0, R0, 7 FFF. And then call 178B. Is that everything? J-Dog, hi. J-Dog says, I also did the Synacor challenge recently in Rust. Where are you right now? The Reg 8 puzzle? Yeah, I'm on the Reg 8 puzzle. So I've got the code, the algorithm extracted, and the hint was in the output was to re-implement it and optimize it. So right now I'm just struggling on re-implementation because apparently my re-implementation is wrong. It's not behaving the same way as my disassembled code. So I got to figure out which thing is going wrong. So here's the I, right? So for 0, 1, we push. Oh, let me separate these guys so I can put them side by side here. Oh, I didn't mean to do that. Oh, that's annoying. I didn't mean to move it into the... Okay, let me quit out of this. Oh. Exit. There. Okay. So this should track this code here. Hello, Kafka. How are you? I've got about 20 minutes left before I have to go, and unfortunately, this has taken me way too long to try to figure this out. So this is the problem right here. Is where we hit. Oh no, here's 2.0, right? It's after this we end up with 2.0 instead of 0.2. That's the problem. J-Dog says, I also had trouble with that. In the end, I implemented a call flow graph for the critical function to get a better overview. Okay. I don't know how to do that, but I will think about that offline if I can't solve this one right now. Because it seems like I'm close. I'm just getting something backwards here. So we just got called with 0, 1, which is this line here. And then it says jump if true, which is false. So it should say add R0, R1, which it does. It gets 2, 1, which we see here. Then we return. Right, so return. If we're called with 0, 1, we're returning 2, 1. That makes sense. And then after we return, there should be another return, and that's not what's happening. That's 79F. Oh. Oh, I'm missing a line here, aren't I? 79F should have a return. When I did the extraction yesterday, I guess I messed up. Okay. That explains that. So where is that? That's after this this call here for this algo. So after we set R7 to R1, we call the algorithm and then just return. Okay. Well, now this is all messed up, isn't it? I don't know how to reset all this. Oh, it's right here. This gets a return. Okay. So let's put that there. And then just say return R0. Okay. I wonder if there are other statements I messed up. 79F, that's A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, 90. Ah, I'm also missing 91. Oh, wait a minute. A8, A9, AA. Okay, sorry. A, B, A, C, A, D, A, E, A, F, BO, B1, B2, B3. Okay, so maybe that was the only thing I was missing. Is this return here. All right. We still got a Stack Overflow. I have no idea if this is working, but it is giving us different numbers. Here's the 0, 1, and then there we go. We called it with 0, 2, which is what we were looking for over here. 0, 2. Okay, so we fixed that bug. We still have a Stack Overflow though. So let's grab call 178B, and in here I can grep for, oops. Grep for C colon. And see, these should all match, right? All the way to 1, 0, 0, 1, 0, 2, 1, 3, 1. Okay. And does this get into the 10s here? Oh, it doesn't. Okay, so I have another bug. Let's see where they diverge. Here's 0, 4, then 2, 5, 2, 4, 2, 3, 2, 2, 2, 1, 2. Ooh, we're missing 2, 0. Could that be because I memoized it or something? Maybe. But I would still print out the call. Yeah, I still print the call out and then look up to see if it happened. Okay. So there's another bug here. There's 1, 3, 1, 2, 1, 1. Oh. It should go to 1, 0. Is that the first mistake? 4, 1, 4, 0. 3, 1, 3, 0. 2, 1, 2, 0. 1, 1. 1, 0. 0, 1. 0, 2. 1, 3, 1, 2. 1, 1. Ah, okay, here's another bug. From 1, 1, it should go to 1, 0. And it's going to 0, 3. All right, so this is a bug we'll have to solve tomorrow, unfortunately. I was hoping we get past this, at least this part of it, today. But it is not to be. Let's see, who else is anybody else streaming Rust? Nobody else is streaming Rust. Let's see who's in my followers list. I can raid. Oh, Boppy Games. I guess we can go see Boppy Games. What's Boppy Games up to? Science and technology. Oh, he's building a motherboard or building a PC. All right. Well, it looks like nobody's doing Rust, so I'm gonna say so long. Take care. I hope everybody has a great day, and thanks for hanging out with me. Tomorrow, hopefully, it'll go a little bit better with this, and we'll figure out what the second bug in my translation of the algorithm is. Building a motherboard would be much more exciting. All right. Then let's go rate them. I don't have a problem with that. All right. Take care, everyone. I'll see you tomorrow.